All right, so here's a limit that involves factoring. So we know we can factor the numerator. That's pretty easy. We're going to have the limit of x minus 3, x plus 2. Okay, and over something. We don't know what that is yet, but let me just write this as approaches negative 2. The bottom may be a little bit more difficult to factor out, but I'm going to show you guys how to do it. If I can get this to work, here we go. So we need to factor out 3x squared plus 5x minus 2. Now the way I like to do it is I like to multiply the first coefficient and then the constant, and I get negative 6. Now I ask myself, how can I get, what two numbers can multiply each other to get negative 6 but also sum up to positive 5? And that is 6 and negative 1. If I multiply 6 and negative 1, I get negative 6. And if I add them, I get 5. So these are the x terms that I'm going to be adding to factor out here. So I'm going to have 3x squared plus 6x minus x, that is from the negative 1, and then minus 2. And now I can see that I can factor out a 3x in the first two terms. So, and by the way, this is called grouping. So I factor out the 3x, and I'm going to be left with x plus 2. I factor out a negative. I'm going to be left with x plus 2. Now I group them together, hence the grouping factor, and I get 3x minus 1. And then I just have to rewrite x plus 2 once. And that is the factored form that I'm going to have in the denominator. So 3x minus 1, x plus 2. Now I can see that I can cancel out the x plus 2. So I am left with the limit of x minus 3 over 3x minus 1 as x approaches negative 2. Now I can substitute the negative 2 into the function, and I will be having negative 2, parentheses, negative 2 minus 3. I don't know why I like to leave the parentheses, but I just do. 3 times negative 2 minus 1, so I am left with negative 5 on top. And then I have negative 6 minus 1, so I am left with negative 5 over negative 7. Two negatives make a positive. My final answer is 5 over 7.